Similarly, when you approach the value x close to 0 from the left side, all the values here are close to -2. Limit of a function when x approaches to 0 from your right side, the value of the function is equal to 2. You can see for all the values x less than 2 or greater than 2, the functional value is 2 itself. Hello everyone, a warm welcome to one and all. This is your Shruti ma'am lecturing in Vidhyaashram, the Temple of Excellence, Mysuru. In our previous session, we have learned what do you mean by limit of a function. Let us see by taking few more examples to study about limit of a function. So discuss the limit of a function f of x is equal to 1 when x is less than or equal to 0 and 2 if x is greater than 0 at the point x is equal to 0. So let us study behavior of this function, whether the limit exists or not. So let me write the graph of this function. So here they have clearly said for all the values of x equal to 0 and less than 0, the value of the function is 1. So for 0, I'll take this as 1, I'll take this as -1. For 0, the value of the function is 1. And for all the values, they are equal to 1. Less than 0. Now, for x greater than 0. X greater than 0, the value of the function is 2. So here, let me take this as 2. At x is equal to 0, the functional value is 1. So here, for 2, I'll write an open circle because at 0, the value of the function is 1, not 2. So I'll write an open circle there. And for all the values of x greater than 0, that is for all the positive values of x, the functional value is equal to 2. So the graph looks like this. Now I have to study the behavior of this function at the point x is equal to 0. So this is the point now. You can clearly see as the value of x approaches near to 0 from the right side for all the values of x that is equal to 2. That is limit of a function when x approaches to 0 from your right side, the value of the function is equal to 2. And similarly, when as x approaches to 0 from the left side, the functional value is equal to 1 because it is clearly said for all the values x less than 0, the functional value is 1. So therefore, when you take the value near to 0 from the left side, the functional value is equal to 1. Clearly, the left hand limit and the right hand limit do not coincide. That is, their values are not same. So therefore, we write limit does not exist. So limit does not exist. Next question. Discuss limit extends to 2 f of x where f of x is equal to 3, a constant function. We have to discuss the limit of a function near the point x is equal to 2. So the given function is a constant function. We have studied in the relations and functions chapter. A constant function is a straight line parallel to x-axis. So therefore, it is given f of x is equal to 3. So the function, this is y is equal to 3 or f of x is equal to 3. So now I have to define the function at the point x is equal to 2. Let me take this as x is equal to 2. Now when I approach from the right side or from the left side, you can see for all the values x less than 2 or greater than 2, the functional value is 2 itself. So clearly I can say my left hand limit and right hand limit is same as the functional value. So therefore the limit exists. And therefore we write limit of a function as x tends to 2, f of x is equal to 3 only because it is same for all the values of x since it is a constant function. Discuss the limit of a function f of x is equal to x plus 2, 0, x not equal to 1, x is equal to 1. So, for x not equal to 1, the value of the function is x plus 2, and for x is equal to 1, the value of the function is 0. So, let us write the graph. So, the function at x plus 2, I'll take this as 1. Now, at 1, the functional value is 0. And for not equal to 1, for all the values not equal to 1, that function is x plus 2. So, if I substitute x is equal to 1 here, it gives a point 0, 3. So, here I'll write an open circle because at 1 the functional value is 0. So, it cannot take the value 3. So, therefore, I have written an open circle here. Next, at 0, it is equal to some 2. So, this is the point 0, 2. And let me take this point as minus 2, 0. So, this is a line, we'll get a straight line. This is how the function is defined. Now, clearly observe, as x approaches from the right side, the value of the function almost comes near to 3. And similarly, as x approaches near to 1 from the left side, the value of the function also goes near to 3. So, clearly what we can write here, limit as x goes near to 1 from the left, the value of the function is equal to 3. And similarly, the limit of a function as x goes near to 1 from the left side, the value of the function is also equal to 3. So, that is my LHL is equal to RHL. So, what I'll conclude, limit exists. So, therefore, I can conclude limit of a function f of x as x tends to 1 is equal to 3. Next question, discuss the limit of a function f of x is equal to x minus 2 for all x less than 0, 0 for x is equal to 0, x plus 2 for x greater than 0. So, if I plot this in a graph, so for x is equal to 0, the functional value is 0. And for x less than 0 means, so for all the negative values of x, so the functional value is x minus 2. So, this is how we'll get the function. So, this point is 0, minus 2. And similarly, for x greater than 0, it is x plus 2. So, this is a point 0, 2. And for all the values greater than 0, it is x plus 2. So, the graph goes like this. Now, let us see at the point x is equal to 0 from the right side as well as from the left side. At the point x is equal to 0, the functional value is 0, but for all the values x greater than 0, that is close to 0 but greater than 0, clearly the functional value is 2. So, that is from the right side, the functional value is 2. So, what I can write? My right hand limit or the limit of a function as x approaches to 2 from right side, the value of the function is equal to 2. Similarly, when you approach the value x close to 0 from the left side, all the values here are close to minus 2. That is my left hand limit of a function as x approaches to 2 from left side, the value of the function is minus 2. So, clearly we can say here the right hand limit is not equal to the left hand limit. So, therefore, what we can conclude? We can say the limit of this function does not exist. Next, we have discuss the limit of the function f of x is equal to sin x at x is equal to pi by 2. So, we have learned the graph of a sin x. So, at x is equal to pi by 2, the value of the sine function is 1. So, if I take this as 0, pi by 2, pi, 3 pi by 2, 2 pi. So, this is 1 and minus 1. The maximum value of the sine function is 1. So, here I can draw the function like this. So, this is your minus 1 and this is plus 1. Now I have to find the limiting value at the point x is equal to pi by 2. So clearly you can see that is from the right side. When you approach from the right side, the value less than pi or greater than pi by 2, but very close to pi by 2. So the value of the function here almost approaches to 1 only. When it comes near to pi by 2, the value of the sine function approach near to 1. Similarly, here also the graph, clearly it shows that when you approach close to pi by 2 from the left side, the value of the function also goes close to 1. So clearly what I can conclude, so limit of a function as x approaches to pi by 2 from left side, it is equal to 1. Also, limit of a function as x approaches to pi by 2 from left side, it is also equal to 1. So therefore what I can conclude, my left hand limit and right hand limit is same. So therefore limit exists. Clearly I can write limit of a function as x tends to pi by 2, the sin x value is equal to 1 or equals to 1. So this is how we will study the limit of a functions given. So in our next session, we will take few more problems on limits and also study the algebra of limits. Until then, keep watching, keep learning and keep exploring. Thank you.